Hello everyone, welcome to today's video. Today we are going to discuss solving absolute value inequalities. So the topics which we cover today is what is an absolute value inequality? Remember the meaning of absolute value. Two main cases, two types of absolute value inequalities. When to discard a solution and tips for the students. What is an absolute value inequality equation? So an absolute value inequality equation look like this. See, the examples are here. So absolute value of x minus a less than b, absolute value of x minus a greater than b. What does it mean? So absolute value of x minus a less than b mean the distance between x from a. The distance from x from a is should be less than b. So this is a set of values. The range mean x distance between x and a should be b. So this is why distance between x and a should be greater than b. These are the conditions of the absolute value inequality equation. So x minus a, or absolute value of x minus a less than or equal to b, absolute value of x minus a greater than or equal to b. So we will see in the next section in detail. These are some examples of absolute value inequality equations. So the meaning is, it means you are finding x values. The x values are unknown. So you are finding all the x values that makes the distance from x to a. So x to a, the distance between x to a less than or greater than b. So this is a fixed value, it's a constant value b. So we are finding all the x values which makes the distance from x to a less than or greater than of b. This is the definition of this absolute value inequality equation. Example. So here, absolute value of x minus 3 less than 2. The meaning is, we need to find all the values of x which makes the distance from 3 is below. The distance from 3 should be less than 2. So before finding, first we need to see the possible values of x. Okay, so that we need to solve this equation. So first, what I'm going to do is opening the absolute value. So open absolute value is, we have two set of values, so two equation. X minus 3 less than 2, the first set. Okay, the first one. So we are solving this. We're having x minus, this is the second set will be minus x minus 3, because the second one is we need to consider the negative side, less than 2. So the two, when opening the absolute value, we need to consider both cases, because there is an unknown value x inside the absolute value equation. So we don't know whether it's negative or positive, so we need to consider both cases, positive and negative. So just solve this. X minus 3 plus 3 in the left side, that's 2 plus 3. So 3 and 3 we eliminate. So x less than 2 plus 3, 5. So we have a first set of x value, x. In the second case, so there's a minus x minus. So let's make the left hand side positive. So multiply minus 1 on both sides. Minus 1 into minus x minus 3. Okay, less than minus 2 times minus 1. Why we making this is to make the left hand side the positive. So while making while multiplying a negative value on the all sides of inequality equation, what we need to do, we already discussed in the previous video, we need to reverse the sign. So here the left hand side will be x minus 3. So we are reversing the sign to this, greater than. So then right hand side will be minus 2 times sorry, this is a positive 2. So positive 2 times minus 1. So it will be minus 2. X minus 3 plus 3 greater than minus 2 plus 3. So minus 3 cancel. So it will be, the equation will be x greater than 1. Okay, so these are the two possible set of x values. So while just I will explain you, I will show you in the graphical representation in the number line. Let's draw this x less than 5. So this is 5, x is not included, so make the open a circle. So x less than 5, so it will go like this, okay, to the minus infinity. Then x greater than 1, so 1 is also not included, so like this. So I'm just going for the positive infinity. Okay, now what we need to do, we need to make both condition true. Okay, the both conditions should be true. So we need to look for the overlapped region. So which is the overlap region here? Here, this one. This is the overlap region. So 1 and 5, between 1 and 5. So 1 and 5 is not included. So the overlap region is 1 and 5. So the possible values of x is x value is equal to, in the interval, we will see in the interval notation, open bracket, because the 1 is not included. So 1 comma, both 1 and 5 are not included. While making this into the inequality equation, we will say like 1 less than 1 less than x less than 5, between 1 and 5. So this x is greater than 1 and x is less than 5. This is the one inequality equation. X is greater than 1 and x is less than 5. So x lies between 1 and 5. So x lies between 1 and 5. If you want to check the answer, you can substitute back and try. So we are substituting back. Just take a value between 1 and 5. Let's make 2. So 2 minus 3 less than 2. Is it true? 2 minus less than 2? Yes. Minus 1 absolute value less than 2. Yes, correct. Then make another value 4. So let's 4 minus 3 less than 2. Is it true? 4 minus 3 is equal to 4 minus 3 is equal to 1. 1 less than 2. Yes, correct. 1 less than 2. Yes, both are correct. So this is how we check the answer. So this is the solution of this example is x values is lies between 1 and 5. This 1 and 5 is not included. Okay, this is how we solve an absolute value inequality equation. So in coming forward, we will see more examples. Okay, the next topic is remember the meaning of absolute value. So we just want to recollect the meaning of absolute value. The absolute value of x, what is the meaning? Distance of x from 0 on the number line. So this is a 0 here, number line. Whatever the value of x, the distance left hand side or right hand side, negative direction or positive direction, no matter which direction, we will only consider the distance. Okay, so we just as example here, absolute value of x less than or equal to 3. That means the absolute value, that means the distance from x, distance from 0 to x is must be equal to or less than 3. So let's open the absolute value sign here. We already know when we open the absolute value equation. So x lies between minus 3 equal to 3. So x lies between minus 3 and 3. We already know that. So that is, I will draw in this number line. So this is the closed circle in the both 3 and minus, because it's included. So this is the range of this absolute value equation. So inequality involved absolute value represents the range of distance. So the absolute value of x less than or equal to 3 is not a single value. This is the range, a set of values we can apply, we can substitute to the x. We can, the possible values of x is a set of values which lies in this range. Okay, any value lies in this range, we can consider the as a values of x. But in the outside this range, see, outside this range, we cannot consider, we cannot take the values, we cannot give the values to the x, because if we go outside this range, the distance from 0 is more than 3, is greater than 3. So we cannot consider this one. That's what we mean by this inequality equation. The distance from 0 to that value of x should be less than or equal to 3. We can take value here, we can take value here, we can take value here to the x, we can give value to the x to this range of any value, but outside the range, no, we cannot do that. That's what we mean by an absolute value inequality equation. There's two main cases. So actually there is two types of absolute value inequality equation. So that we need to consider separately, because the first type is less than type. We call it as less than type. See, x minus, say, absolute value of x minus, say, less than b. The same, look at the sign here is less than. Or x minus, say, absolute value of x minus, say, less than or equal to. In this type, we consider less than or equal to sign. Okay, so in this case, we need to apply a special rule. So we'll discuss this rule. So this means, so this less than type means the distance from x to a, the distance from x to a is less than b. The less than b, we already discussed in the previous video, previous example. The distance from x to a is less than b. So x lies between 2 points. You already know x in the number line, the x lies between 2 points. Okay, this is how the less than type look like. So the what rule we apply here is just we just solve for x. So open absolute value, and we will solve for the x. That we already know this. We consider two cases, and we solve for x. Okay, in this case what we're going to do is, so x minus a, absolute x minus a less than b. So opening the absolute value, we have two cases, x minus a less than b, x minus a less than b, x minus a less than b, and x minus a greater than b, where minus b is there. X minus a lies in between minus b and b. Okay, x minus a lies between minus b and b. This is how we then we solve for x. So this is how the rule applied for when we have a less than or equal to. So we can directly write this equation whenever we having an equation less than type, absolute value, inequality sign, directly jump into this type of equation. So we can directly, no need to solve, no need to go for splitting and separately splitting the equation, solve separately, no need, just directly write into this kind of inequality equation. So this is the less than type. This rule apply only for the less than type. Okay, just try this example here. So example 1 is x minus 3. So absolute value of x minus 3 less than 5. So in this case, what is the sign here is less than. So as per our previous rule says, we can directly write this equation like this. So x minus 3 is lies between minus 5 and positive 5. Okay, this is the, as per the previous rule, we can write and jump into this equation, and they solve for x. So how it solve for x? To eliminate this 3 from here, we need to add. So x minus 3 plus 3 in this side, so 5 plus 3 on this side, and minus 5 plus 3 on this side. So this 3 and 3 eliminated, so the final equation will be minus 2 less than x less than 5 plus 8. So this is the x values lies in between minus 2 and 8. So the interval notation will be minus 2, because minus 2 is not included, right? Comma 8. So that's why we are using an open bracket. So the x value lies between minus 2 and 8. So just graph this one in the number line. So the first one, x is lies between minus 2. Minus 2, where is minus 2? Yes, open circle. And where is 8 here? Yeah, here, open circle. So just connect this together. Before, what normally we do is just open the absolute value, then split the two equation, compute for the separately x values, then finally we combine number line and take the overlapping region, or we use intersection. So like that we are doing. So when we having this rule with less than type rule, we can directly jump to this equation from this equation. Okay, next type is greater than type. So here x minus a, absolute value of x minus a greater than b, absolute value of x minus a greater than or equal to b. In this case, the sign, notice the sign is greater than symbol. So the meaning of this symbol is the distance from x to a is more than b. In the previous example, it was less than b. Here it is more than b. So the x is outside the range. So x is not lies in the range, it's outside the range. Okay, because more, we are talking about the value more than a specific value. So it's outside the, here how we will solve in this method. There is no special there is no special easy method. We can solve as usual. How we solve? Open the absolute value sign, consider the two cases, and solve for solve separately, and find the possible x values, and put and merge it using a union symbol. So here this is an example here, x minus 2, absolute value of x minus 2 greater than a 4. So while solving this, we need to take on two condition. This is I'm directly going to the condition. So x minus 2 greater than 4. So x minus 2 than minus 4. This is the two condition I am having. So then we can directly put it in the number line. First we will solve these values. So first one is x minus 2 plus 2 greater than 4 plus 2 is equal to x greater than 6, the first x value. The second one is x minus 2 plus 2 minus 4 plus 2. So the 2 cancel. So x less than minus 4 plus 2. This is minus 2. These are the two cases, and I'm marking this here. So x is less than minus 2. X is less than minus 2 means open circle, it will go like this. Okay, you know, x is greater than 6. So here open circle, greater than 6. So these are the two separate parts of the interval notation. So going for the interval, it's like minus infinity comma minus 2, both are open bracket. Here 6 comma infinity, both are open bracket. So this two interval, the x lies in between, in this two interval, not between, the x lies in this two range. So this there is no common, overlapping area. This is two separate interval. So in this case, what we do is we need to combine this two interval, two ranges. We need to combine these two ranges. So we have to use a union, a symbol. So in here, the union symbol will look like minus infinity comma minus 2 notation, union 6 comma infinity. Okay, these are the values we can apply to our original equation to satisfy the inequality condition. Okay, let's see an example here. So x minus 2 greater than 4. So this is the example we saw already. So here what we're going to do is less than minus 4, because I'm directly jumping to this, because we just reverse the sign, because multiplying this -1 on the both side. So I'm just directly rightly. So in this case, I cannot write it in a single inequality equation. Because why? Because these are two separate parts. So x minus 2 greater than 4 and x minus 2 less than 4. So that is two separate parts. So the this value will lies less than 4. It's greater than x minus 2 greater than 4 means this region, and x minus 2 less than minus 4 means this region. So these are separate two parts of the number line. So we cannot write it in a single equation, single inequality equation. Okay, so we need to solve these two equation separately, and we need to combine them. So x minus 3. So while doing that, x, then just convert this into the interval notation. So x greater than 6 means x should be lies between 6 and positive infinity. Both are not included. In this case, x lies between minus infinity and minus 2. So minus infinity comma minus 2. So this is a simplified form. So no need to do all the computation, because we already know that how to write this inequality symbol directly. We can compute and directly write it in interval notation. So we have two intervals. So x lies between 6 and infinity, and x lies between minus infinity and minus 2. So just combine these two. Before combining, just visualize this in this number line. So minus 2 to infinity. So minus 2 here, and infinity will go towards the minus infinity. So then x is 6 going towards the positive infinity. So this is the two separate region, so two separate range. So just combine using a union. So we need both this value. We can apply this range of values and this range of values to the x. So both we need to combine using a union function. So we can write minus infinity comma minus 2, the first range, union 6 comma infinity, the region. So it's very simple. Don't make it complicated. Don't go for the each step by step. While doing the practicing the problems, we will come to know how to jump into the solution. So the interval notation is, this is the interval notation. So this is where graph shade the left minus 2 and the right of 6. So this is the one we shade. This is the region. Okay, this is the region of the x values lies. So another case, see, when we are having a less than or equal to or greater than or equal to, see this cases we have to use dots, comma and square brackets. So in this case, you all already know that we have a less than or equal to. So the interval x plus 1 will be less than or equal to minus 2 equal to 2. So in these cases, while converting this into an interval notation, don't forget to the interval notation minus 3 comma 1. So in this case, this minus 3 and 1 are included. So don't forget to apply this square bracket, because if you apply the open bracket, that means minus 3 and 1 is not included. So the answer solution is wrong. So answer is wrong. So you have to apply square bracket. Why? Because the interval notation includes the both value for all inequality equations. Some inequality equation has a no solution. Okay, so that keep in mind how it will be identified. See, if an inequality equation leads to an impossible condition, see, an inequality equation leads to an impossible condition like distance less than 0. See, distance never be less than 0, because there is no distance less than 0, like negative values for the distance always positive. So there is no solution in such cases. So here, for example, absolute value of x plus 4 is less than minus 2. So minus 2 means it's less than minus 2 means it's a negative value is coming. So never an absolute value never be negative. So in these cases we need to directly say impossible. The distance cannot be negative, so no solution. This kind of inequality equation, no need to further computation. We can directly say there is no solution for these such cases. Okay. So next section is tips for students. So when we having inequality equations which having absolute values, so keep in mind the first point is whenever for having less than or equal to, always look for the common region. So that means and means this intersection. So both cases, so if x less than 5, so in this both can, while applying this in a number line, it might be look like that. So x less than 5 means it's coming like this. So there's overlapping region. So this region is we are taking this region, that means intersection of two interval. So this region we are taking for, normally look for the less than or equal to symbol, that means and. Okay, then the second case is for greater than or equal. So in this case we are looking for outside the region. The x values will be lies outside the region. So in this case the x values might be, this is two separate intervals. So we need to combine this using a union. So or means a union. So we need to combine these two regions using a union. So this is the two cases we need to keep in mind. When we less than or equal to, we need to use and. I mean intersection, the common overlapping area you need to look for. For in greater than or equal to, you need to look for the two separate parts. You need to combine the two parts using a union function. So union. Okay, these are the two cases. Then third one is always check the sign before splitting the inequalities. For example, x minus a less than b. So splitting this one, always look for two cases. So x minus a less than b. So minus x minus a less than b. The later it will go to x minus a greater than minus b. So this is how we do the two cases. So always check the sign. The sign is very important. So use interval notation correctly. The interval notation should be very important. Don't forget the difference between square brackets and open brackets. So square bracket means both the values inside the square bracket are included, but in the open bracket both the values inside the open bracket is excluded, not included. Okay, these two differences you need to keep in mind. Draw the number line to visualize always. See, whenever you having when we are arriving an solution, it's very good to visualize that, because if any logical error or any mistakes, you can directly comes in your mind when we see the visualizing. So try to visualize the inequality equation and the solution of the inequality equation in a number line. So it's good for your better understanding.